Hi, my name is Jaden, and this is my 2211 Lab1. So the purpose of this lab is to test Newton's fundamental law of motion in the real world. This lab focuses on Newton's second law, which deals with momentum and forces. And we're going to test its accuracy by comparing position time data in real life and compare to a computational model to see how it compares. So Newton's second law states that force equals change in momentum or change in time, or also force equals mass times acceleration, and momentum equals mass times velocity. The second law states that if the net force on a system is zero, there will be no change in momentum and the velocity will remain constant. So the procedure I used is to record an object moving in a straight line at a constant velocity, track the object's motion and position using tracker, code the same situation in GlowScript to make a computational model of the situation, and compare both of the data. So for this experiment, I assumed that air resistance and friction were negligible, and I rolled a piece of tape across the table because I just found a piece of tape. That's what I'm rolling, and I started to record the data after my hand stopped touching the tape, so that it wasn't exerting any force, and that the net forces on the piece of tape were zero, and the tape moved at a constant velocity, and I had a little tape measure to track its position. So the initial position was 0.02 meters, initial velocity was 0.259 meters per second, and that was calculated at 2 seconds. So the computational model, you can ignore mass because it cancels out. The equations, delta t is set to 1/30th because the video is recorded at 30 FPS, and the position and velocity formula is used to map the motion of the tape as seen in the pictures of the code below. So here's the graph, and it's a little small, but as you can see, in the beginning, the tape is moving slower, and then it eventually speeds up a little, and then it slows back down. And the reason it's slow in the beginning is just like because of errors in how it was measured by the tracker. But you can see that the computational model is a straight line, while the real life model, the slope starts to flatten out near the end, which means that some forces were acting on the piece of tape opposite to its velocity, accelerating it in the left direction. And the post-lab questions. Oh, why is this broken? What if the axes were flipped and positive x and negative x were interchanged? So basically what would happen, it would be exactly the same, but in the graphs, instead of the sloping positive, it would be negative, because if moving to the right was in the negative x direction, then the plots would be below zero, so it'd have a negative slope. And where the forces, the net force is zero, I would say no, because of friction and air resistance. So if you wanted to improve this lab, you'd find theoretically a vacuum, but that's impossible, or just a really low friction track so that friction has less of an influence. And how many forces were involved? Air resistance, friction, and the slight deformation of the tape as it rolled. And I think that's it.